My room's kind of cold.
No, what are you doing?
I don't know. Alright, real quick here, kind of going through this, remember vocab terms. I'll have 6 blanks here, you have to fill it in. The word bank will be off to the right, kind of like normal, I talked about yesterday. Remember, some of the keywords I skipped that are in this list that are obviously not here. Equilateral, right, obtuse, acute, Pythagorean Theorem, SOHCAHTOA, like sine, cosine, tangent, hypotenuse, angle, side theorem. Those are just some words I can think off the top of my head that are clearly not in that list, but we've definitely talked about, so keep that in mind. So I always try to remind you, keywords I've skipped and things that could be easily in these spots here. This question, remember, you're giving me the letters and the symbols. So like on this number 3, you better have the little M, the little angle symbol, and then the letter that matches corresponds to letter E. So keep that in mind. This, number 4, you want the number. Down here, number 5, you want a little angle symbol and 3 letters after that correspond to E, H, and O. That's an angle, by the way, on these 3 letters. This problem right here, it's a yes/no originally for each one. Are the triangles equal? And then if it's a yes, you have to give me the acronym. That gives the reason. Again, you can fill in markers like reflexive wall, vertical, all that good stuff. You guys know the drill. Proof, remember, whatever style proof it is, you have to give me enough reasons to justify that you actually know what you're doing, that you're not just getting lucky. You have to, if it's a flow chart, it's gonna be really important that you give every reason. Okay. This one right here, you have to show their work. I think it was only 2-3 lines, something like that. But you have to solve for x. Make sure you're doing that. Remember, don't do the silly mistake where you add up things to equal 180. That's only if they're angles. I'm not trying to find angles here, so keep that in mind. Okay. All right. These are the problems we started yesterday. Perfect. Thank you. Okay. So some of the things we started yesterday. We talked about, how to simplify radicals. If you typed that problem in your calculator and you got the decimal, you did not do the problem. That is not what I want. I do not want a decimal in that top problem there. You had to simplify it by breaking it down and circling pairs and kicking them out of the house. We talked about that yesterday. This problem right here, we talked about the altitude and the leg theorems. The formulas are actually still on the board. I left them up there from yesterday. Those are the 2 over there. You have to show the work. That problem, this problem right here, is worth a lot of points. I think 9 points. That is worth almost more than that proof we did. So keep that in mind. Don't skip that problem on the test. Take your time, do it right. Get the answers. Leave them square roots if you need to. Okay? If you don't remember how we did that one, watch the video from yesterday. I posted it even before we were done with school yesterday. I posted it in the afternoon. So it was there all night. We talked about this problem. This problem you have to do Pythagorean Theorem to solve for x. Just remember what I talked about yesterday. The problem doesn't always have to look like that picture. They could rotate the picture. You could be finding a different wall other than the hypotenuse and where the x would go in the Pythagorean Theorem. It could be different. Okay, so just be careful. The answer could be a square root. We talked about yesterday, like this problem was a nice perfect number. The example I also did, the second example, was a perfect number, but the one on the test, if it doesn't work out to be a perfect square, just leave it a square root. That's fine. You can simplify it from there. But show the work on those. And this problem we spent actually a lot of time on yesterday talking about, how to know if it's a triangle or not before you even start. And then if it is, how to check what type it is. And we did that one yesterday. That's where we finished, correct? We finished there? We're going to move on today. We're moving on to the back page. This should be your 4th and final page. Now, turn to the back of your practice guide. Does everyone have these problems? I had one person yesterday, Taylor, that didn't have the back page for some reason. Like everyone else did, but that one wasn't printed correctly. Okay, everyone's got it though? Everyone's got that back page? It's got a bunch of problems like this? Okay. Alright. So let's go through a couple of these. I'll kind of pick 1 or 2 of these that I want to go through. I think let's start with maybe let's go through number 2 maybe here, just so you can kind of see this. And then maybe I'll pick a problem like maybe number 4, 2 and 4. Let's do those. That way you get to try one, I'll try one, and see how it works. And then the last problem we'll draw and all that good stuff. Question?
For the problem to have 2 angles.
Yeah.
You can just choose whatever one
Yeah,
you want.
exactly. That's why we're gonna pick number 2, and that was the reason why I picked this one. Yeah, if you didn't quite get what Miss Nelson's asking you, this problem has 2 different angles, right? It has a 63 and a 27. Just pick one of them. It doesn't matter which one you pick. The answer will actually work out to be the same with whatever trig function you pick. So I'll let you guys have choice. 63 or 27?
63.
63, sorry, I heard that one first. So 63, so we're gonna get rid of this one. So that one's not even there anymore. Okay, so now we're using the 63, this is my angle, this is my theta. We have to label the walls. Why label the walls? The 3 labels you have is you have opposite, adjacent, and hypotenuse. Okay, so these are the labels we're gonna throw in. Why I'm throwing those labels in there is because once I have the 2 out of the 3 labels thrown in, then it tells me which acronym to pick, which trig function to pick out of SOHCAHTOA, because SOHCAHTOA relies on those labels. That's what those little letters in the back mean. Opposite and hypotenuse, adjacent and hypotenuse, opposite and adjacent. So it tells you which trig function to pick. It's not just a free-for-all. It's actually one specific one for the angle you chose. So if we're picking the 63, let's label my triangles. So like on this, what is this wall called?
Opposite.
Opposite, okay. So again, opposite's always straight across from your angle. This angle, or this wall line? Okay, adjacent. And it looks like we're not using the hypotenuse in this case, which is fine because that's this wall over here. The hypotenuse never moves. That's always the same wall. So it looks like we're not using that one. So which one of the 3 are we picking? Tangent. Yeah, we're picking tangent. Now the reason why we're picking TOA, because if you look at the back letters, they use opposite and adjacent, O and A. Those are my labels for my picture. That's how I know which one of the 3 to pick. The trig functions are on the board. They're over there. You can see them. They are clearly labeled like what the fractions are, what the formula is for it. But on this one, this is why you have to pick TOA, is because the labels tell me that. So T stands for tangent, so tangent of 63 degrees is equal to, and then the letters here, it goes the second letter on the top, third letter on the bottom. So opposite's on the top, adjacent's on the bottom. The opposite wall is X, and the adjacent wall is 12. So in this case, it looks like the X is on the top, so there's the number on the bottom. So how do we solve for X? Yeah, move 12 over. Since 12 is on the bottom, you would actually just multiply it across. So 12 times the tangent of 63. And that's how you solve for X. And that's exactly how you type it in. And so if you have a calculator like mine, you can type it in 12 tan 63. Now, if we have any other kind of weird calculators in here, let's say like Hanson, you kind of have a strange one there. I think you have to type it in backwards, 63, the tangent button, then type times 12. I think same with Dalton, I think yours the same way. I don't know, who else has kind of unique ones? I think yours is maybe the same way, I don't know, I can't tell. You have menu driven, you'll be able to type in just like me. Anyone else having struggles with typing it in? What do we get for the answer here?
23.55.
23.55? 23.55. That's X. Did anyone not get that number? Now obviously tomorrow the lights will be on, so hopefully if you have a solar calculator it will actually work. And you can see the formulas up there a little bit better, so you can kind of tell which one to pick. And how to set it up, where the numbers go. Okay, questions with that? But everyone got 23.55 though? When you typed in question?
Would you want us to round it up to like 23.6?
I usually, I think up above it says like 2 decimal places. That way we're all getting kind of the same thing. I think it says 2 decimal places at the top.
It says to the nearest 10.
Oh, okay, so 1, yeah. So if you go 0.6 it'll be fine. I'll probably have 2 or 3 written down, just to make sure kind of what people have. So yeah, it'll be fine. Questions on that one though? Now, let's say, okay, I'm gonna come back to this problem though. Let's say you didn't pick the 63. Let's say you didn't pick that one. Let's say you picked the 27. You'll still get the same answer, which is insane. But you'll still get the same answer because you'll set up a slightly different trig function. Like the setup will be a little bit different, but you'll still get the same answer, the 23.55. So let me prove my point here. So let's say you pick the 27 here. Okay. So you're the person that picked 27, not the 63. Okay, so then you labeled your triangle, so this is the opposite wall to your 23. This is the adjacent wall to 23. And you know out of SOHCAHTOA, you had to pick this one again, so you're picking the same trig function, but the setup looks different, right? Because you picked 27, so you went tangent of 27 is the opposite over adjacent. So opposite wall is 12 over the adjacent wall, which is x. So now, since the x is on the bottom, if you were doing it this way, you would have a slightly different setup than the person that did it with the 63. So if you have the x's on the bottom, you have to do that little switcheroo thing like I talked about, where if the x is on the bottom, you switch it with the tangent of 27. Like that. So you'll type in 12 divided by tangent of 27, and guess what? You get the same number. You get the 23.55 or 56. Okay. Make sense? Everyone get the same number? It's cool that it works any way you want, as long as you understand the setup, like you understand how to work that. Now, if you have a kind of a different style calculator, like Hanson, I think yours is kind of the same way. For you guys will have to figure out if you're doing it this way, you have to figure out what the tangent of 27 is as a decimal. It's a crazy decimal across the screen. And then take 12 divided by that weird decimal. 12 divided by whatever that decimal is. So you guys have kind of a two-part problem if you do it that way. Okay, questions at all? Is anyone not getting this however way I'm explaining it? Like, if you have questions like, I don't quite get that, or can you do another example? Obviously, we're going to do another one here in a minute, but not quite sure why we're setting it up the way we are. Again, it's not always tangent. This problem required tangent. You might be using sine or cosine, so just kind of be well aware of that. We're good though? Okay, let's go to the next one. I think I'm going to pick number 4, and why I'm picking 4, they have a couple different letters on there. So I want to talk about how to do that problem. There's like 2 or 3 different ways you could do that problem, but I want to make sure everyone's good with this one first. We're good though? This one? Okay. All right, and again, I just showed you 2 different ways in case you didn't like the way that I did it over there. Maybe you picked a different angle. All right, let's go to number 4 now. All right, number 4. This one, the picture's drawn a little goofy. They've kind of rotated the picture. It doesn't matter how the picture looks as long as you understand where the opposite wall is, the adjacent wall, and the hypotenuse. On this one, which wall is the hypotenuse?
The 120.
Yeah, the big wall, the 120. That's the hypotenuse. You got to understand that. The hypotenuse will never move. So just kind of keeping well aware of that, this is the hypotenuse. It's the big wall. It's the only wall that doesn't touch 90. I don't care how they rotate the picture. So just kind of be aware of that, because some people wouldn't know that. They think it's the adjacent wall. They think it's the opposite wall, whatever. So, all right. This problem, since there's 2 letters, you have to find both of them. It is 2 problems in one. I would recommend go after one letter first, and then go after the second letter next. Like, think of it as 2 different problems. So I'm going to go in alphabetical order. I don't know why, it's just the way I'm going to do it. So I'm going to go after X first. So I'm going to ignore the Y. It's like the Y isn't even there. I'm going to go after X. So I'm going to do the normal thing that I always do. I'm going to label the triangle without caring about the Y. I'm just going to ignore the Y for right now. And I'm just going to do this problem as normal. So the 58, what is this wall called? Opposite. So, and then we already have the hypotenuse labeled, so we're good. So now, if I'm thinking about SOHCAHTOA, obviously I'm using hypotenuse, H, and I'm using opposite, O, so that would be this one. That's the only trig function that uses O and H's in it. So that's the one I have to choose. So that's why I label the picture. It tells you which one to pick because of the back letters. The front letter is the trig function. So I'm using sine. Sine of my 58. Second letter goes on the top, so opposite's on the top, that's X. Hypotenuse is on the bottom, that's the 120. And then to solve, I would multiply this across. 120 sine 58. Now I'm expecting this to be kind of a bigger number, maybe not 3 digits, but probably a 2-digit number, kind of bigger. What do we get?
I got 1.7.
Ooh, okay, do we get a 3-digit number? So say it again.
101.7.
101.7, so kind of what everyone's
Barely.
getting. Just barely a 3-digit. I was expecting a 2-digit. But I guess the angle is kind of big, it is 58, so. I was expecting maybe 80s, but yeah, that's the other wall. Okay, anyone not get 101? We're all getting kind of the same thing. Does everyone understand how to type it in their own personal calculator? Now remember, like I only have 10. There's more than 10 of you in here, so whatever calculator you're going to use tomorrow, maybe you're going to use the same ones, but just make sure you know how to use it, because I don't answer those questions on test day. Like how to use your calculator, how to type them. So if you're not getting those, you got to ask questions today, or today after school, or whatnot. We're good with that though? Okay, now, I'm going to put the 101 in there. Okay, so this is a 101.7 if that's what we wanted. Okay. Now we have to go find y. You can find y two different ways. You can do Pythagorean Theorem, because it is a right triangle, and it is one missing wall out of 3, so you can do it that way. Or you can do it with another trig function. It's whatever way you feel comfortable. So I'll give you guys the option. Do you feel comfortable with Pythagorean Theorem, or do you want the trig functions? Trig. Okay, let's do it by trig. Okay, so we're going to do it by trig functions. Okay, so same thing again. Now I'm going to go after the letter y by doing another trig function. So I want to get rid of the x. I don't care about that, even though we already know what x is. I'm going to go after the y. The y, if I label the picture, because I always label the pictures, this is the adjacent wall to my 58. That's the adjacent wall. It's right next to it, and then we have the hypotenuse. And now I'm going to pick out which trig function. Well, it looks like if I'm using adjacent and hypotenuse, I have to pick this one, a and h. Adjacent and hypotenuse. So that's why I'm going to pick cosine to find the letter y. So cosine of 58 is the adjacent wall, second letter's at the top, so adjacent over hypotenuse. So adjacent is y over the 120. And then to solve, I'm going to multiply the 120 across, because it's on the bottom. So 120 cosine 58, and that will help me find the y. And what do we get for this one? I'm expecting something smaller than 101.
63.5.
Oh, that'll work. 63.5. Is anyone not getting those numbers that we're coming up with? They sound reasonable, so I'm going with it. I mean, that sounds pretty good to me. And again, we pick the trig function. So if you're going to pick a trig function to find a letter, label the walls, just start over, ignore the other letter, even though I know it's a 101. I would just label the picture, and then you should be able to find it. Now, if you were the person that wanted the Pythagorean Theorem, we could have done this Pythagorean Theorem because we knew that this was a 101.7. You could have done Pythagorean Theorem. This is A, this is B, this is C, because it is a right triangle. These are the legs. So y squared plus 101.7 squared equals the 120 squared. You'd have to square these. Those are insanely big numbers. Subtract that number over. Once you figure it out, whenever that number is, you take the square root of it. And guess what? It's 63.5. Well, so it's the same thing. So if you did it by Pythagorean Theorem, it would work out. Maybe you'd have more decimals because your calculator approximates everything. But you'd be in the ballpark. At least the first couple decimals will probably be exactly on. Questions? Okay, hopefully that makes sense. I like to give you multiple options for doing these so you're not stuck with one method. You can do it by any method. Now, obviously, why I chose Pythagorean Theorem there, because you had 2 out of 3 walls. You don't need to do trig functions in that case. But if you like the trig functions, stick with it. I mean, they're easy enough. You know how to type them in. They're pretty quick as long as you understand the buttons of which ones to pick. Okay, we're good though? All right. Last problem of the day. We're going to do the final 5th problem on this back page, I guess, which is the story problem. Okay, this one, the most common mistake that people make when doing this story problem is they don't draw it right, which I always find funny. It's like they're explaining everything what it is, but people won't even attempt to draw it, which I think is funny. Like that'd be the fun part of doing that problem. So you're flying a kite, you have a string attached to it, so I would draw the ground, draw a person holding a string, and a kite flying up in the air. That's what I would draw. Okay, and I'm going to do that here in a second. Okay, all right. So let's start here. So we have ground. I'm going to color code this. So we have ground. Here's my ground. Here's me. There's me. And I'm holding a string. going up to a kite. There's my kite. Okay. Now, let's fill in the numbers where they need to go. So hopefully you can see there is a right triangle there. There is a right triangle. Okay, there's an altitude, going up there. Obviously this line wouldn't be there in our story problem, but we have a right triangle there. So the angle of elevation, that means looking up. Angle of elevation is looking up in the air. So the angle of elevation is 40 degrees, that's me. It's a 40-degree angle. There is 80 meters of string. So where is that at?
The string.
Yeah, the hypotenuse, the string, like it's the hypotenuse, right? It's the thing attached to your kite. Okay, so there's my 80 meters of string. That is a really long distance, by the way. Was that 240 feet, something like that, roughly? Ignoring the sag, so there's, I know the string is not perfectly pulled all the way, unless, but we're ignoring that. But find the height of the kite. So we're going to find how high is it off the ground, not the distance on the ground, from the point directly below it, but how high is it off the ground, the actual altitude of it. So, it's a trig function, right? It's not a Pythagorean Theorem problem because I don't have 2 out of the 3 walls, but it's a trig function, right? It's SOHCAHTOA. We have to label the triangle, find the number. So let's label the walls here and then I'll let you kind of finish this one by yourself. So, we have an angle. What is this wall called?
Opposite.
Opposite wall, okay? And this wall?
Hypotenuse.
Hypotenuse, all right. And again, that's the hypotenuse, the reason why it doesn't touch the 90. These are the legs, so. All right, so now that we know that, we can figure out which one of the 3 trig functions to pick because of my label. Bless you. It looks like we're picking opposite and then hypotenuse, so we're picking that one. So in SOHCAHTOA, sine. Because that's the one that uses opposite and hypotenuse. And then you can do it and figure out the number. The height's got to be less than 80 meters. The hypotenuse is 80. The number going up and down has to be smaller than that. And when you find it, show the work. Show the work that you're doing, the trig function you're doing. Show what answer you get, and label it. What's your label? Meters. Has to be meters. If you forget labels, I do count wrong. Don't forget it. Okay, I would expect something very similar to this on the test. A story problem where I give you enough information, you can draw a mock little picture of it, figure it out, and I'll even give you little clues as we take the test, like what you're doing there. Questions? All right, the rest of the time is yours. You have about, 8-9 minutes here. You can work on your practice guide. You can type stuff in. Remember, your goal today is to make sure you get this wrapped up, finished, completed, however you want to say it, and you're ready to turn it in tomorrow. We're taking tests tomorrow. Make sure you have a calculator and all that good stuff. Okay? All right, the rest of the time is yours. I'll set the camera, and I'll try to get this posted today.